Okay, this video here is about parabolas and how to change standard form equations into graphing form. The first thing we need to do is to look at your skills in writing equations for parabolas. So let's try a question here first and see how you do. If I told you that I had a parabola here at 4, 1, a vertex at 4, 1, and a stretch factor of 3, would you be able to write the equation? Pause the video now and see if you can do that. Alright, now hopefully when you look at this information, you're hopefully noticing that the graph, when you have a graph shifting 4 to the right and up 1, the parentheses part that you're going to see with the x is opposite what you see. So when you see a graph shift 4 to the right, you need to put x minus 4 in the parentheses. If you see the graph move up 1, then at the end of your equation you put a plus 1. The only other trick to the question is this first number. That first number that you see in the equation is your stretch factor, and that's already given to you in the problem here. This stretch factor again tells you the size opening, whether it's going to be stretched or compressed. The larger the number, the more stretched out it looks or skinny it looks, and the smaller the number gets to 0, like a fraction or a small decimal, the wider the graph gets. Now let's try again another problem just like this and see if you can find the equation of this one. Pause the video now and see if you can do this. Alright, this graph here shifts 2 to the left and up 5, so hopefully you can write an equation that's going to have x plus 2 because the graph moves to the left 2 units and then goes up 5. Also, you're going to notice that the stretch factor is at negative 0.5, which means the graph's a little bit wider, as you noticed here, and it's opening down because it's negative. So when I know the information here, there's two things if you know these two things about a parabola, you can write the equation. So what we need to remember is, whenever we have a problem and we know the stretch factor and we know the vertex, we can write the equation. Have some confidence with that. Alright, moving forward. Did you also know that the equations that you've been writing here are called graphing form equations? The reason we're calling these graphing form equations is because you know everything about the graph. We know the size of the opening, the direction of the opening, we know the vertex based on these two numbers here, h and k. There's a lot of things you know about the graph when it's written in this format. But there are other formats that are out there. And this format is called standard form. Standard form equations are another way to write the equation for a parabola. You've done this earlier in the school year. When you worked with factoring, you factored equations like this, and you were able to find x and y intercepts. You also used the quadratic formula. The quadratic formula uses a, b, and c when solving the equation for x, when y equals 0. So there's a lot of things you've noticed about these already that you've worked with, but you didn't maybe know that the name of that equation was called a standard form of equation. Now, the next thing I need to have you look at is if an equation were to start out looking like this, what is it there that you notice that's the same about both equations? Pause the video and think about what these two equations are, or what's similar about the equations. Alright, what I've heard from other people is that these equations both have squareds in them, which make them both parabola equations, but more importantly that you're going to notice that they both have the letter A in front as the same letter. That is intentionally done that way because this A and this A are both the stretch factor in both equations. So if they both have the A and you know the stretch factor, you're already halfway there to finding the equation from a standard form equation and getting it into graphing form. Because again, to write a graphing form equation, if you know the vertex and you know the stretch factor, you can write the equation. So in this problem right here, do you know the stretch factor? The answer is yes. It's that first number. It's the A value right here. The A, B, and C is the same A value that you see down here with the A, H, and K. So I know the stretch factor. So my next question is, do you know what the vertex is? Well, when you look at this, you might be wondering, I don't think I can see the vertex, obviously, in this format, so the next best thing to do would be to get out your calculator. Your calculator can help you find these things. So take your calculator out now and see if you can enter in this equation, and let's see if we can find the vertex. I'm going to walk you through some steps here on how to find the vertex, so please follow along and do the steps on your calculator with me as I go through this. Alright, so after you've entered your equation in, the next thing you need to do is hit the graph button. You may or may not be able to see the entire parabola on your screen. So the next thing you have to do is press the window key. So press the window key, as you see down just below your screen, you'll see a window key down here. And what I need to have you do is change the settings so that you can look farther down. The way you do that is by going to the Y minimum to change that. So change your Y minimum to negative 20. Then press the graph key just to make sure that it all fits. Now that it all fits, you're going to then press second trace. The trace key is right here. The second button's over here on the left-hand side of your screen, or of your keypad, and when you press those buttons, you'll have this menu show up here on your screen. Now if the parabola is opening upward, you want to find the bottom or lowest point where the vertex is going to be found. If the parabola is a negative A value here in front, then it would probably be upside down and you want to find the maximum value. So in this problem here, you want to find the minimum because it's the lowest point on the graph is where you're going to find the vertex. So after you press minimum, then I want you to go on your screen and press the left arrow on your keypad till your cursor gets to the left of the vertex. Notice the bottom of your screen is going to say left bound. That means get the cursor to the left of the vertex, then press enter. Once you do that, then it's going to ask you to find the right bound. So move your cursor over to the right of the vertex, press enter, and then it'll then ask you to guess, and then after you press enter one more time, your screen will tell you the word minimum at the bottom, and then it will give you its best guess as to what the vertex is going to be. Now your calculator will not be perfect. It will have sometimes rounded numbers here, or numbers that are very close to the right answer. In this case here, if you were to round this to the nearest whole number, in this example, it would be -2, -12. So if I know the vertex now, and I know the stretch factor, do you now have enough information to write the equation? And the answer is yes. So if I know my stretch factor is 2, I'll write my equation y equals 2 with a pair of parentheses. To make this vertex shift 2 to the left, I'm going to put x plus 2, and then after it, to get the graph to go down 12 units, you're going to say -12. So now what we've done is we've successfully transformed this equation right here, which is in standard form, and now gotten it into what we call the graphing form. This format right here can tell you a lot more about the graph. This format here can tell you a lot more about the intercepts. Okay? So let's have you try one on your own now and see if you can solve this one. So pause the video, see if you can find the stretch factor and the vertex, and then find the equation. Alright, now that you have had some time to work this out, hopefully you took the steps through and found out the vertex to be at -2, -30, and the stretch factor was the exact same number here as you see here. So your stretch factor will be at 4, as you saw, and hopefully shifting your graph to go 2 units to the left, you should get x plus 2 squared, and then to get it to go down -30, this is what you should have gotten. Hopefully this is enough to give you a good start, at least, on transforming standard form equations into graphing form. I hope this helps. Good luck, and we'll see how you do.